Hello everyone, welcome to my presentation titled Closer to Continuous Delivery with Knative. My name is Mauricio Salatino and I'm working as a staff engineer for VMware. I do work 100% of my time on a project that's called Knative. That's the one that I will be talking about. I am definitely a Kubernetes addict person. I've been working with Kubernetes for the last 6 years and I don't see that changing. I really like the environment, I like the community, I like all the projects that are being built on top. And because of that, I do enjoy building frameworks and abstractions on top of Kubernetes and tools for developers to use and be more efficient. And I do share all my learnings in Twitter. I'm at Salaboy in Twitter, and I do have a personal blog that is called salaboy.com, where I share, what I'm doing every week, and I enjoy interacting with people and explaining and mentoring people out there if they want to contribute to open source projects. So if you are into that, feel free to reach out. So today's agenda, it's pretty simple. I do not have long time for this presentation, so I will just try to keep it as short as possible. And the focus of the presentation is about continuous delivery for developers, right? I will be trying to share why I think that Knative is important and how it can bring us closer to continuous delivery. So continuous delivery for developers, in general, I talk about continuous delivery in the sense of we want to iterate faster, we want to deliver more software, and when we're building cloud native applications, this is basically just creating new releases for your services, right? But I will not be talking about how do we create the releases. I will be talking about the mechanisms that Knative provides in order for us to go faster in real life applications. And I will be demoing an application with some features around Knative. So if we are talking about continuous delivery, you definitely need to know about the Continuous Delivery Foundation. The Continuous Delivery Foundation, you can visit their website, is cd.foundation. It's basically a place where different projects and different tools can go there and share ideas to kind of like try to standardize how do we do continuous delivery for cloud native applications and for other applications as well. So I encourage you to take a look at the website and see the projects that are involved in there. You will find a lot of stuff that is super interesting. So if we are talking about cloud native applications and a cloud native workflow, right? Like how do we create these cloud native applications that are running on top of Kubernetes? We are basically talking about a bunch of tools that we will need in order to basically build our services, deploy our services, version our services, and all the things that are related to that, right? So, and that's usually a lot of infrastructure, right? Like we need to understand how all these pieces works together, how Kubernetes works, how do we create pipelines, for example, using Tekton or Jenkins X, for example, and then using, kind of like GitOps approach has become really kind of like dominant in the last few years. So understanding some of the GitOps principles might become really useful for us to be more efficient, right? And there are like projects like Argo CD and Jenkins X that basically are providing some implementations of these flows and this approach and basically trying to automate as much as it's possible, so you as a developer don't really need to care about how the software is built. You just configure it once, it kind of works, and then just focused on building your services, right? And that's basically the last point in there. Like these tools are super necessary. We need to understand how they work. We need to get familiar with them. We need to know how they work on top of Kubernetes and what do we need in order to basically run applications on top of Kubernetes. But none of these tools will help us to architect our services, right? None of these tools will help us to basically test new features, have like a flexibility around which versions of these services are we running. How do we measure if one version works better than the other? How do we do A/B testing and this kind of stuff that is very useful when you are creating a cloud native application, no matter how small it is, right? So my findings, or at least my personal opinion, is that Kubernetes is too low level, right? Like, and this is kind of like common in general, right? Like for a developer, understanding what the deployment is, what a pod is, what a replica set is, what an ingress is, it's all fine. It's something that as a developer I can understand, but by just knowing those concepts, I'm not basically focusing on building my application. What I'm saying is that usually what we need is some higher level abstractions that will try to solve us like all the problems that we will have like on everyday, like the everyday challenges, right? Like, and bring some kind of like good practices on top of how do we use these low level constructs in order to just be efficient and deliver services, right? So what happened next after you have all your pipelines set up and you start kind of like building your services and delivering new versions of these services, right? What we should focus on is on iterating faster, right? How do we go from a feature branch where we created a feature to something that is deployed and running that we can test and it's in front of our users, right? How do we tackle the challenges of building distributed applications, right? Like connectivity, how do we decouple services so they are not so tightly coupled that we cannot deploy them independently. And again, how do teams make changes on these services and keep delivering features without being blocked by each other, right? These are all concerns that start to appear when you have more than one service, right? Like the moment that you have two services, two different teams building services, they will need to rely on contracts and define a way of working so they know and they are enabled to keep releasing features. So what is Knative? In that context, we want to deliver more and more things more faster, right? Like we want to make sure that we build our services in a way and we deploy our services in Kubernetes in a way that it's more efficient. And we allow teams to just rely on these other abstractions that are simplified abstractions on top of Kubernetes building blocks. And that's basically what Knative is, right? Like we can see Kelsey here like tweet about like if Kubernetes is the electric grid, the Knative is the light switch, right? And that's basically saying that we have this complex set of concepts in Kubernetes, right? Like deployments, services, ingresses. I consider those as like Lego blocks, right? Like when you think about like a generic bag of Lego blocks, like pieces that you can do whatever you want with them, that's pretty much what Kubernetes concepts are. Knative instead is just like these predefined sets, right? Like if you want to build houses or cars, you have sets with the specific, windows and doors and, like wheels for the cars. So in this case, Knative is just going one step above and building abstractions that are more kind of like suited for common things that you want to do, right? And in this case, the commonality here is building cloud-native applications. And what do you usually need in order to build cloud-native applications? With Kubernetes concepts, you can build whatever you want, and that's very unopinionated. Knative becomes a little bit more opinionated in the things that you can build and the things that we will be simplifying for you. There is one thing that I wanted to mention here. It's that the fact that Knative is heavily associated with serverless, and that's something that, at least in my personal opinion, sometimes it hurts the Knative community because it's not just serverless. Again, it's just a bunch of abstractions, and this, as this slide mentioned here, is a bunch of abstractions on top of Kubernetes resources, right? So it's all about best practices and architectural patterns applied on top of those basic concepts, so we can concentrate on what matters for the business, right? Like we can concentrate on building our services for our distributed applications. For me, it's definitely something that it's a bunch of abstractions that enable us to go faster and improve our continuous delivery practices, right? Knative is divided into two main components and modules. We have serving in one hand that I will be demonstrating and eventing in the other, right? Again, if you combine these two things together, you can definitely have like a serverless architecture there, like a serverless infrastructure platform that you can use. But that's not the only thing that you can do, right? And I think that by mentioning that, what I want to accomplish is that to change that idea that Knative is only serverless. Knative is a bunch of tools, a bunch of abstractions that you can use to build cloud-native applications. If you want to use the idea of serverless in your applications, you can use that. But if you don't want to use it, you're fine as well, right? Like you can have normal services without like downscaling them to zero. And the other thing that is important to mention here, that serving and eventing, they are independent, so you can use them together. They play really nice together, but you can also use it separately. So you can use the serving part or the eventing part, and nobody's going to push you to add the other modules. You can install them separately as well. Usually I get this question, how do I get started? And I tend to recommend people just to go and create, a Kubernetes cluster in a cloud provider. I have this link that I created some time ago about like free Kubernetes credits, right? Like you can go to that link and you can go to different cloud providers. They will give you free credit to create Kubernetes clusters and try stuff. You can go there, create your Kubernetes cluster, and then install Knative on top, following the documentation, which is pretty straightforward nowadays. Or you can create a local dev environment using conk or Knative on kind. This is basically creating a new cluster in your local machine with Docker containers and then installing Knative components on top of that. Okay, so let's talk about Knative serving. Knative serving provides a bunch of abstractions on top of how do we create services inside Kubernetes. So it provides its own version of what a service is, right? Like in Knative, by default, we have services and deployments. And these concepts are highly simplified by the use of a Knative service inside Knative serving, right? So if you have Knative serving installed, you can create Knative services. And this will allow you to basically have these features that we have here on the right. So we have advanced routing for traffic. And it's pretty made simple because Knative also installed like a networking layer that allows you to configure how to route traffic to different versions of your services at, by configuration. It does also include the auto-scaling part of it. This is kind of like what is usually associated with serverless. If you have in Kubernetes, if you have a deployment, for example, you cannot have 0 replicas for that service. If your service is not being used, at least it will have 1 replica. In Knative serving, you have that possibility. So you have the autoscalers that are monitoring the services and to see if the services are being used or not. And if they are not getting any requests, they can be downscaled to 0, right? Like that's kind of like why Knative is associated with serverless. In the same way, if the service is getting tons of requests at the same time, the autoscaler will automatically scale up until a bunch of replicas that are defined also in the service configuration. It also allows you to run multiple versions, multiple revisions at the same time of the same service. That basically means that Knative by default, it will create a configuration here, as we can see on the left. And every time that we change the configuration of the service, it will create a new revision. So when we firstly deploy the service, we will have 1 revision. And every time that we change something in the configuration of the service, a new revision will be created. And it also creates a route that it's automatically exposed. You can configure that as well. So you don't really need to create an ingress. It's going to be automatically exposed to the users to access. And basically what that route does is basically redirect traffic to a fixed revision, right? By having kind of like this scheme of things and these concepts, you will be able to redirect traffic to different revisions or multiple revisions at the same time. And Knative will keep all the revisions that are needed by the application running. So you don't really need to worry too much about, how many versions of the service do we have running. If you have a route pointing to a revision, Knative will keep it up and it will know how to redirect traffic to that specific revision. I will be showing that into the demonstration later on. In general, all these resources like route, configuration, and revisions are created, but the only thing that you care about as a user and the only YAML file that you define is the service. That is basically the parent resource here and the one that will generate, like we ask Knative to create all these child resources that Knative will automatically manage for you, right? So let's take a look at that in action so you can see how multiple revisions can be used for real life scenarios. And I've created a simple application that will demonstrate kind of like these concepts in action, and I have that already running in Google Cloud Cluster. So the application, it's pretty simple. It's composed by 4 services. We have a user interface, that it's the service that we are going to access using our web browser, and the service, like the application, is composed by these other 3 backend services: the agenda service, the call for proposals, and the email service. We are simulating a conference website, right? So we have all the items that are in the agenda, all the presentations that are already confirmed, and we have also a call for proposal service that is basically accepting new proposals for potential speakers. And we have an email service that is basically sending notifications about the proposals. Because of these services, we will concentrate on a simple flow, which is the call for proposal flow that looks like this, right? So we go into the application user interface as a potential speaker, we submit a proposal, that proposal goes to the call for proposal service, and there the conference organizers can accept or reject the proposal. It doesn't really matter if you get accepted or rejected, an email will be sent by the email service. So the authors, the potential speakers, are notified if they got accepted or not. And if the proposal is accepted, we are going to publish that into the agenda of the conference that you will be able to see in the main website. So let's switch to the application to see this flow in action. Okay, so the application, it's pretty simple, right? Like as I mentioned before, we have the agenda service, that it's this service that you can see here, that it has 2 days in this case, and 4 accepted presentations. We also have the back office to go and accept the submitted proposals, and we also have here the submit new proposal button, and I can submit one. So for example, Knative in Islamabad, Salaboy at mail.com. This is a test proposal, right? So I can submit this proposal, and as a potential speaker, I cannot do anything else. I just need to wait for the notification from the organizers. And basically, if I go to the admin site here, like these are all the received proposals, and I have one that I need to decide if I need to accept or reject, right? If I accept this, it's going to be showed into the agenda service, and also an email will be sent saying that I was accepted for the conference, right? So if I accept that, I should be able to go back and see that that talk was scheduled for Saturday the 21st, right? So pretty simple flow. All the services are communicating via REST, in this case sending REST requests to other services, and this application, as I mentioned before, is running in a Google Cloud cluster here that I've created for this meetup, and I've installed all the services in there. So let's take a look a little bit about how the application looks like from a Kubernetes resources perspective, and then let's start changing the configuration of the Knative services that are running this application, so we can take a look on how they behave. All the services that I'm running here are in this repository. You can basically follow the same steps that I'm following right now. And I will be sharing this URL so people that it's interested, in running the same example, they can do it, right? And again, this is pretty simple. I totally recommend you to check it out, because by trying it out on your cluster, you will kind of have first-hand experience on using these tools. Let's switch back to the terminal now. Okay, so if you follow this document that I'm going to be sharing with you, you can basically install Knative serving in one of your clusters, and then install the application which is composed by these 4 services to use Knative. I'm doing that with Helm here. This is kind of like the important line. And then I'm setting the services to be using Knative here as well, with some flags and some URLs for the services so they can interact between each other. If you follow these instructions, basically you are going to have the same setup as I have here. So I can jump to my cluster and I can start using kubectl to interact with the services and to start changing them as well, right? So the first thing that I want to show you is that I'm using K as an alias for kubectl, and I can get all the namespaces. So you can see that I have Knative serving and Knative eventing installed, right? And I also have Courier installed as my Knative kind of like networking layer as well. That's why I can configure like more advanced like traffic, rules for traffic routing in this case. Right. So if I list all the services, I can do that by listing all the resources that are called Knative services in this case, and I can see that I have 4 services, right? Like the API gateway, which is the front end, the call for proposals, the email service, and the agenda service that I've showed you before, right? Like the flow was using all these services. And what I can do now is I can start changing the services, so we can start creating new revisions for the services, and we can see in action how can I have multiple versions of the same service running at the same time, and how can I direct traffic to these two different instances, right? So in order to do that, we can also first list the revisions. For example, this is another Knative resource, right? And we can see that we have 1 revision for each service because we just deployed the application and it's the first configuration that was applied. Then we can start generating new revisions, for example, for the front end. So if you follow the instructions here, that's guiding you to do this. Basically, we are going to edit one of these services, the Knative services. Edit. Edit KSBC. And in this case, we want to edit the API gateway again, but it's the front end service. The only thing that I'm going to be doing is I'm going to change the configuration, and by the configuration I mean in this case the Docker image that I'm using. So imagine that you are making a change and you want to test that change with your users to see which user interface they like more. So I have another Docker image with that name, color, which basically has a different color scheme, and then we can do some A/B testing on that. And then you're up to define, okay, how do you want to route traffic to this new version of the service that you have? So basically what I will do is I will create new rules here for the traffic section on the Knative service. And I will just copy this section here, which is basically defining 2 different revisions. Revision number 1, right? That we want to send 50% of the traffic to that revision, and the newest revision with this new Docker image, the other 50%. So if I save that, we get from Knative that the service was updated. And if I list this again, what I should be able to see is that there is a new revision created by Knative. And if I do list the pods in my cluster, I will see that now I do have 2 different pods for the API gateway, right? But if I list the services, right, I will see that I still have the same URL, right? Like that basically means that I have a route pointing created there that is basically going to direct traffic to the 2 different kind of like instances that I have. And it's going to do that based on the percentage traffic that I've defined. So if we go to the site, right, and let's see if the pods are up and running. The pods are up and running. So I have so I have one instance of each of these pods plus some extra sidecar that is being injected by Knative. So if I go to the application now and I hit refresh, I should start hitting different versions of the service, right? In this case, if I hit refresh again, I go to one instance to the previous instance. And then if I hit refresh again, I go to kind of like a new version of the application with a different color scheme, right? By doing this, again, you can define maybe 10% of the traffic should go to the new version to see how it behaves. And then you can ask feedback to that 10% of users to see if this version is better than the main version, for example, right? And again, it was pretty easy. Imagine that you will have a team creating these changes like designers, and then you can just go ahead and do that, right? Like you can just actually go and test this in your, let's say, staging environment or in your production environment, and to limit the impact to 10% of the users if that version is causing any issues. Now let's switch to another feature here, which is basically using tag revisions. We can create a tag and then use that tag in a header. So only users with a specific header are going to be able to access one of these revisions. Now imagine that you want to troubleshoot some issues with your service instances, right? For that, sometimes you need more information, and showing that information in the user interface might make it easier, but you don't want like regular users to access that information, right? So in these situations, you can definitely use headers. So developers can use these headers in order to see more information about the services and how they are running. So let's do that change by using a different Docker image that is showing more information to the user. But again, let's not expose that to normal users, just for developers to access that. So again, we were going to edit the front end, right? Like we can just edit the user interface to use a new Docker image. And again, by doing that, we are just going to generate a new revision, and we are going to once again change the traffic rules. So so we can just only direct traffic to this new revision for developers that are using a specific HTTP header, right? So in order to use this specific HTTP header, what you need to do is, like, let me remove this again and copy this from the document here again. So this is just 3 rules that are basically saying we want to send all the traffic to the original revision that we have, right? Like version 1. We want to send 0 traffic to the revision that we are creating now, that it's revision 3, right? And we don't want to send anything to the latest, which is the one that we are creating now, basically, right? So the only way for us to reach version 3 is by using a header, setting a specific Knative header with this value, debug, in our browser. So when we generate the request to the server, Knative will understand this. The route will just send requests to this new instance of the service that will be created now. So if I save this, so as soon as the new service is up and running, right, like we have our 2 versions now that are being used by the service, like version 1, which is the original version, plus the one that it's kind of like have the debug flag enables, just deployed and up and running. That basically means that we can start directing traffic to it. So I come here and refresh. You will see that no matter how many times I refresh, I'm going to go to version 1. That's the stable version for the users. But if I'm a developer and I want to troubleshoot something and I want to see version 3, I can use something like mod header here, which is a plugin for Chrome that enable me to add some headers to the request that I'm generating. In this case, I'm using this header that's called Knative serving tag with the value debug. That's the name of the revision, the label, the tag for the revision that we created in the configuration. And as soon as I enable this, I should be able to access the other version of the service that it's basically adding more information, right? It's showing that Knative is enabled, and the name of the pod that it's running this service, in this case is the agenda service, the node in the Kubernetes cluster where the service is running, and more information that usually we don't want to expose to end users, right? Again, this shows kind of like the possibility to use different techniques to route traffic to different versions of the same service that you're using, and enabling you to have multiple versions at the same time, trying them separately in a controlled way, and making sure that you do that in a simplified way without creating tons of different Kubernetes resources just to do some testing, right? I highly recommend you to check these features out, because again, they are super useful for when you're building real life applications. And in the next section, we are going to be looking a little bit more at eventing, which adds another set of abstractions that are pretty helpful for building cloud native applications. So if you have any questions about serving, please feel free to ask there in the chat, or reach out via Twitter. I have my DMs open, so just please get in touch. Great, so if we talk about Knative eventing, it's a separate module, as I mentioned before, and this module basically provides abstractions to connect event producers with event consumers in a very decoupled way and in a very declarative Kubernetes way, right? So what we are doing here, it's basically defining what are the events producers, having concepts like brokers and triggers in order to be able to route events between different services, and enable kind of like developers to connect these services at runtime when they are deploying the services into different environments. Right, so this image on the left, basically it's showing different event producers. Let's say that you want to connect to GitHub and listen to all the repositories events that are being generated, or events coming from other Knative services, or from other Kubernetes services, or events coming from Kafka, right? And you need a way to route those events to multiple services, to multiple consumers. It can be one or many. And in order to do that, basically what you create are triggers, which are basically subscriptions of saying, I'm interested in this kind of events, please send those events to this service whenever they happen. And you can target as consumers like Knative services, Kubernetes services like the default ones, or anything that can be addressable, which is an interface provided by Knative, and you can implement more of those. So in Knative, the project provides different sources and different implementations for these brokers, right? Like the main idea here is that when you are building cloud native applications, you don't worry about the implementation of the broker of that router. It can be RabbitMQ, it can be Kafka, it can be Amazon SQS, it can be Google PubSub. It doesn't really matter where you are running this or which implementation are you using to move events from one place to another. The only thing that Knative is allowing you to do is to define this conceptually and then choose different implementations for different brokers, depending on where you're running and your preferences, right? So one important thing for Knative eventing is that it relies on cloud events, which is a standard specification by the CNCF on how to exchange events metadata, basically. And by using that standard, it allows us to connect any consumer with any producer that is actually using cloud events. And that's the default format for all the Knative brokers, which is pretty important when you want to standardize and connect different applications together. So basically what I will be doing now is I will enable the services that I have in my application. So the ones that I've showed you before and the flow that I've showed before, like the call for proposals flow, to emit events. These events are going to go to a broker that I will create in my environment, and I will show you where it is. That broker has an URL. So the only thing that the services needs to do, it needs to send, an event to that broker, and they can do that via HTTP. So they can send that event like it's a post request to the broker, and that broker implementation, it might be Kafka, RabbitMQ, again, Google PubSub or Amazon SQS or some other implementations. It's going to pick up that event and redirect to any trigger that it's defined, any subscription that it's waiting for events to happen. So what I will do in the demo is I will install an application which basically is showing all the events that are happening. I will create a subscription for that application, so all the events are redirected to that application. And then I will go and enable all the services in my application to emit events whenever something happens against that service, right? So when I send a new proposal, I want to send an event to the broker saying, hey, I received a new proposal. This allows me to have visibility about what's happening in my application in a very non-intrusive way, right? Like I don't need to change my services too much in order to generate these events. And I'm exposing what's going on inside the services, so I can keep track of different metrics. For example, I can start building dashboards saying, a proposal from the moment that it was received to the moment that it was approved, it took this amount of time. So let's take a look at that demonstration and to see, if I can show you how events work in action. So going back to the document, you will see that there is another section for installing Knative eventing and just running this example that I'm going to be running now. The first thing is, of course, installing Knative eventing. And then, as I mentioned before, we use this concept of Knative broker in order to define this router for events. And you can create a Knative broker pretty easily by just copying this command. And if I create that broker, if it wasn't created, it will be created. If it already exists, it will tell me that it already exists. So I can list all the brokers that I have here in my setup. And you will see that I have the URL for this broker. So if I want to send an event to this broker, I just need to send a post request to that URL, from any service that I have running in my application. And then that event is going to be forwarded to the broker, and then the broker, based on the subscriptions that it has, it's going to forward that event to all the interested parties. So what I can do is, first of all, I will install a new application. This basically is just a sockeye, which is basically an event visualizer. So you can see all the events that are happening and that are being forwarded to this application. So because this is also a Knative service, I can see that it's up and running here, and it has a URL that I can access via my web browser, right? So again, if it's a Knative service, it's automatically going to create a route to it, and it's going to allow me to access. So every time that I send a cloud event to this application, I will see here one entry in this list. The next step, as it's mentioned here in the document, is to basically edit one of these services and just switch some flags. In this case, enabling the events, so the application knows that it needs to send events, and then I need to provide the URL for where the events needs to be sent, in this case the broker URL, right? So let's do that. I will just edit my service, and as I mentioned before in the previous section, this will generate a new revision, but we want to keep a single revision for this, so I will just not create any crazy traffic rule for this revision. In this case, what I'm changing is like an environment variable, like 2 environment variables in general in this case. So let's just change that. Let's add these 2 environment variables. Again, one is enabling sending events, and the other one is defining where to send those events, right? I'm doing this for the call for proposal service, which is the one that is basically orchestrating the flow. So it's the one receiving the proposals and then deciding what to do. And we can try that first, right? And as soon as I've done that, enable the service to emit events, the events are going to be sent to the broker, but the broker doesn't know where to send them next, right? Like, because there is no subscription created. So the last step here is to create that subscription, and I will do that by creating, this object and send that to Kubernetes basically. So I think that I have it here. So if I go to Knative, I think that I have the trigger object, which is that one. And basically what this trigger object is doing is saying, I want to subscribe to all the events that happen in the broker, in this case in the default broker, and I want to send them all to this URL, which is the URL for my application, the event consumer in this case. In general, when you are creating triggers, you can also specify filters. So there is no need to send all the events to all the subscribers. You can filter the events for only the ones that your applications are interested in. So if I apply this as any other resource, like my trigger, the trigger will be created, and now I should be able to see events flowing to the sockeye application in this case, right? But in order to generate events, I need to go and use the application. So I have sockeye in there, I have my application in here. What I can do is I can testing events, I can send a new proposal. Yep, testing events, right? So I will send this, and because again the call for proposal service is enabled to send events, I should be able to see one event popping up here. And in this case, we get the information about what that event is about. In this case, is the call for proposal service proposal received event that was emitted, and I'm getting it here in sockeye basically. If I go to the backend, to the back office, and accept or reject this proposal, I should be able to see that another event was created, which is basically that a decision was made, right? So this is basically showing eventing in action. You can imagine that you can integrate multiple applications by emitting events, and it should be pretty easily to add any other application or any other consumer for your events based on this approach. You create new subscriptions, new triggers for the broker, so the broker knows where to forward these events to. I hope that that's clear and you could understand. And again, I encourage you to follow the tutorial, because me showing you the application is one thing. When you go and try these things out in your local environment or in a real Kubernetes cluster, you kind of like grasp why all these features are super important, and how by relying on events you can create more complex integrations and more decoupled architectures that are not heavily, tightly coupled together, and you can use that kind of more an event-driven approach. So I hope you liked it, and let's go to the Q&A now. Applications to show more than 2 services communicating and interacting. So when you're trying these applications, for example, you can go and try to break them, and see how they behave and how fault tolerant they are. You can, of course, create multiple replicas of your services and put the application under load to see how it behaves. And you can experiment and have kind of like an example that it's ready to go for you to go and try new technology on top of it.
Yes, absolutely. Because I think as there's a lot of the confusion around because Knative has so many things you can do with it, like say eventing, the serving. Then we have another feature that's called the routing the traffic between the different services, like Canary deployment, the AP and dot launch deployment. So there is so many wonderful things you can do with Knative, and in able to understand how to demo out all these features. It's really a difficult job, but I think you did a tremendous job of at least showing us what the Knative is and what eventing is. And now, because we have cleared out the session, so just tell us, describe why eventing is so important. What are the feature is available outside the Knative landscape, and what is interesting in Knative if we use eventing with Knative?
Yeah, so Knative eventing, it's its own module, right? Like as I mentioned in the presentation, you can choose to use only Knative eventing. And I think that it's really important because no matter what kind of application are you building, events are going to come up sooner or later, right? Sometimes you are planning to build, for example, an architecture, like an event-driven architecture where events are like must. You need to have events and you need a way to move events around, right? Like you need like an event router where you send an event and then the router will decide where kind of like who is interested in that event and route that event to all the services. That basically allows you to create these very decoupled architectures where you can create producers and consumers that they don't know about each other. And then when you are deploying the application, you can configure and wire these components together, which allows you to integrate with other applications or to configure the same application, the same services to connect to different services, which is a pretty important and pretty common pattern to follow when building distributed applications or when you are integrating different applications together. So Knative eventing makes kind of like all that work pretty simple. And it also allows you to not make a very difficult decision, which is which messaging implementation do we need to use, right? Like you can start simple, for example, with some in-memory implementations, and then you can move to Kafka or to RabbitMQ. And then if your company says, I don't want to use Kafka or RabbitMQ because I'm running on Google, you can just switch to Google PubSub, and you don't really need to change anything on your applications because you are relying on these abstractions. So from that point of view, that's a pretty good kind of like set of features. And when you go deeper into eventing, you can see that they're like filtering, they're like redelivery on events, and all these things that will make your application more robust.
Yes, and another question from my side is that let's say the eventing is so important because the cloud native application it relies on some kind of events. Let's say today my application is used by 10,000 of people, and tomorrow I see that only 2 people are using my applications. So I need to tear down these extra pod that is came up because of the let's say the holiday or some kind of Black Friday or these kind of activities, and we spun up millions of pod together. So how Knative is helping me with that? If let's say is scraping the metrics out of the Kubernetes and sees there are very few users left for the application. Now I need to tear down the extra pods that are hanging around consuming memory and CPU. So can you draw some point on how Knative work with that environment?
Yeah, definitely. So Knative comes with its own like autoscalers, which are like Kubernetes concepts that basically monitor metrics and then define if you need more replicas or less replicas. And you can configure the parameters to kind of like influence how the autoscaler will work. So how many requests, concurrent requests are you planning to support with a single replica? And then how many replicas, the autoscaler is able to create to make sure that you have enough resources to run all those replicas, right? And it works in the same way in the other way around, right? Like if you don't have demand, Knative, the autoscalers will define when the service needs to be scaled down. And Knative add this extra feature of like going down to zero, right? Like if you have zero requests, nobody's using your service, then it's capable to tear down all your pods and just not use any resources in the infrastructure, which is pretty interesting.
Yes, absolutely. Because I think we need this kind of tooling in cloud native apps because containers might be millions and trillions at times, and then you have to tear down. And if you do that in a manual setup, I think it's a pain. It's absolutely a pain.
Exactly.
And
Yep. And this is one of the things with Knative is like whenever you start learning about it, the thing that you will realize is that there are like most of the scenarios that people is building outside, like on top of Kubernetes, can definitely benefit from Knative. So nowadays, if you're using Kubernetes, I don't see why you wouldn't be using Knative, because it just adds more features for making your life easier. That's pretty much it. Unless you are doing something very, very specific that doesn't fit kind of like common and best practices on the industry, then you might not need Knative, but for like 90% of the cases, like Knative will definitely solve a lot of things that you will need to solve anyways.
Yes, absolutely. And so, last question for myself, and then I go to the audience if they have any question around it. So, I have been tracking about the Knative project, and there is none of the peoples I know about in my connections in Twitter who talk about Knative. And once you join the VMware, I see that there is now a person I can know about him, and he's joined the Knative project. So we are doing a session, and we keep on doing these kind of stuff because Knative is one of the best project that I am seeing. They can do so many stuff in one way. So what's next with Knative? What next for the next releases of Knative? What's happening inside the project? What you are doing right now in the Knative? And what's missing right now in Knative? So you can address all these questions.
Yeah. So the next big thing in Knative is releasing 1.0. So the entire community it's working really, really hard to finish up some features inside like the eventing and serving modules to make sure that we arrive to a 1.0 version of the project, because I think that that will bring a lot of adopters into the project, and I think that that's where you're going to see more and more people like talking about it, right? Uh, Sometimes people get scared when a project doesn't reach kind of like that 1.0 milestone. So we are just working really, really heavy on that. It's really interesting because this is a multi-company project. So it's not VMware only, it's Red Hat, it's Microsoft, it's Google, and it's Trigger Mesh as well. There are like a bunch of folks involved and contributing very actively on the project. So what's going on right now is pretty much everyone is trying to figure out what are the missing bits for 1.0, and just try to release that before the end of the year. So I'm hoping that we will be able to see kind of like a big release by the end of the year. And what I'm actually doing right now is working on a specific part, which is conformance. What happens with Knative is that it is a bunch of components that can be provided as a managed service. And Google is actually giving Knative as a managed service, it's like a software as a service, right? So if you go nowadays to Google and you create a Kubernetes cluster, you can click one checkbox that basically will install Knative for you, and you don't really need to do anything else. You will have Knative in that cluster, which is something that it makes a lot of sense. And because of that reason, what we need to do for 1.0 is we need to have a bunch of tests that goes through the Knative specs, which basically define what Knative is and what are the main Knative features. And it allows us to run this test against these managed services like Cloud Run, right? And in this case, so if VMware wants to provide a managed service, we will need to run against those tests and make sure that we pass all those tests in order to be able to say that we are offering Knative as a service. So this is all, company related, and I think that that's really, really important for 1.0. So we are pushing really hard for that to happen as soon as possible.
Yes, definitely. That's all great news for me. So before we let you go, anybody has some question related to Knative or any other topic, feel free to ask right now. And I see the one person has pointed out, do you foresee Knative will be a standard for almost every cloud native app in the future?
It's just a tool, so there are like different options to do some similar things. Knative gives you kind of like a bunch of features all packaged together, and they are all related, and they can all be used, in conjunction in a very good way. So I do see, more and more projects adopting Knative as the, a base layer for building their applications. And I also see like a lot of providers like Red Hat and VMware pushing really, really hard for these technologies in their own offerings, which makes me think that, large companies, the companies that have money and buy these services for service providers like Red Hat and VMware, they are going to have Knative available there. So if they are building applications, they are going to be probably using Knative as well.
Yes,
Hopefully that
absolutely.
makes sense.
Thanks for the clarification. Yes, absolutely. So we won't take much of time of the Salaboy because he's a very busy person. But I really enjoyed the session, and this webinar is going to be available for everyone to watch as on Cloud Native Islamabad YouTube channel. Hopefully, it will be available on Monday, and we will see. I will try to touch with him as Mauricio on the podcast side as well. So there I have a flexibility to ask as many questions as you wanted. But I'm really happy that you showed up, and everybody who are joining today, go follow on Twitter, and he will able to help you in these kind of scenarios. Because Knative is a project where everybody investing from Google to VMware to Red Hat. So I think you have to know what's happening inside the Knative project in the moving forward. And after the Kubernetes big thing that people are talking about right now on the Twitter. And we have a person who can help us adopt to these technologies, Salaboy. Go follow him on Twitter. And thank you, Salaboy. Thank you, everyone who joined us today. And this video will be available on YouTube, I think, on next Monday. Thanks, everyone. Bye-bye. And I'm really appreciate.
Thank you, my friend.
Thanks.
Talk to you later.
Bye-bye, everyone.
Bye-bye.